Good morning and welcome to Connect2STEM. Let's start off with a great welcome from Sunny at the Be Kind crew.
Hey everyone, I'm Sunny with the Be Kind crew and I want to welcome you to Connect2STEM TV, organized by the University of Arizona College of Medicine, Phoenix, in partnership with Cox Communications and the Arizona SciTech Festival. Who's ready to get nerdy? Today, we are going to have fun and work on a STEM project. Be sure to have your materials. Get ready, set, let's go.
Wonderful. Thank you, Sunny. And we also want to take this opportunity to thank one of our new sponsors, Basis Charter Schools. We appreciate your support for all the activities and the fun that we're having today during our STEM sessions. So let's just get started and jump right in to our first presentation. And this is from the College of Pharmacy here at the University of Arizona. And this is called Wonders of the Heart, Hear the Beat.
The heart is the most important muscle we have. And is situated a little to the left from center of our chest between our lungs. It is very special because it sends blood all over the body. Blood delivers oxygen and nutrients that we need to live. A heart is a type of pump, like the one we use to inflate the wheels on our bikes. The only thing is that instead of pumping air, it pumps blood. The heart is divided into two parts, the right part and the left part, separated by a cellular wall, so they are not directly connected. Each one of these parts has two chambers. The upper chamber has two parts called the right and left atrium. The lower chamber has two parts called the right and left ventricle. The heart also has all kinds of doors, which are called valves. These valves let blood in and close behind so that the blood cannot go back. Now that you know the parts of the heart, do you know how the heart works? It all starts in the right atrium where blood without oxygen and nutrients enters the heart. Then it goes through the first valve into the right ventricle. Once it is here, the heart sends the blood to the lungs so that it can get oxygen and nutrients that it needs. And then it goes back into the heart through the left atrium. Then it goes through another valve until it gets to the last cavity, which is the left ventricle. Finally, the heart sends the oxygenated blood through the last valve so that it can be sent all over your body, and then the process starts all over again. To understand how the heart beats, we can imagine a heart is like our hands. If your hand is in a fist in front of you, when it opens up, it fills with blood, and when it closes back, it pumps that blood outwards. When the blood exits the heart, it flows through our whole body through blood vessels. There are three types: arteries, veins, and capillary vessels. Arteries deliver oxygen and nutrient-rich blood to all of our organs and body. Veins then take that blood without oxygen and nutrients back to the heart, and capillary vessels, which are very small, connect the arteries and veins and cells all together. The heart is the engine in our circulatory system, and it is an incredibly strong muscle. It is able to beat more than 100,000 times a day. When we exercise, our heart beats faster because our muscles need more oxygen and nutrients to move, and when we are resting, our heart will beat slower because our muscles don't need as much oxygen and nutrients. It is important that we take care of our heart by exercising and eating healthy food so that our heart can continue to perform at its best.
How a stethoscope works. A stethoscope is used by healthcare professionals to listen to sounds inside your body. With a stethoscope, you can hear the sounds made by your heart, your lungs, and the sound of your blood flowing through arteries and veins. You can even hear the sounds of other organs inside your body, including your intestines. How is it that we can hear all of these things with a stethoscope? First, let's look at all the separate parts of a stethoscope. At the top, we have two earpieces, which should always be facing forward. Below that, we have hollow tubing, which transmits sounds from the chest piece to the earpieces. And then at the very bottom, we have what's called the chest piece. Some chest pieces act as both bell and diaphragm, with pressure determining the function. Other stethoscopes have a separate bell and diaphragm. The bell is used for low-frequency sounds, and the diaphragm is used for high-frequency sounds. The way that the stethoscope works is that when the end of the diaphragm or the bell of the stethoscope is placed against a person's body, sound vibrations travel through the hollow tubing up through to the earpieces, where we hear them. Some stethoscopes have what is called a bell, which is pictured on the top in this image. It's called a bell because it's bell-shaped. This part of the stethoscope chest piece is hollow and has a teeny hole on the top. This helps us to better hear the lower pitches in the body. Not all stethoscopes come with a bell. The bell, which we can see in the picture in the upper right-hand corner, is used by pressing lightly against the skin. Medical providers often use the bell to listen to the sounds of the heart. On the bottom, we see the diaphragm. We use the diaphragm to listen to high-pitched sounds. The diaphragm is large, flat, and circular. It's the disc at the bottom of the stethoscope. As we can see from the image in the lower right corner, when physicians hold the diaphragm tightly against the skin, they can hear the higher-pitched sounds of your lungs, bowels, and heart. Stethoscopes come in a variety of styles, colors, and designs. Here we see a stethoscope with a diaphragm, but no bell. There are also electronic stethoscopes and pediatric stethoscopes. When you go to see your physician for a checkup, they often listen to several areas in the anterior or front of your chest and several areas on your back. This way, they can check to see that your heart and lungs sound healthy. When listening to the heart with a stethoscope, there are generally 5 different areas marked with blue diamonds in this diagram that your physician will listen to make sure your heart sounds normal and healthy.
In the normal, healthy heart, there are 2 heart sounds. The first heart sound is produced by closure of the mitral and tricuspid valves, indicating the onset of ventricular systole as they are pushed shut. The sound of the 2 valves closing normally merge into one. If the sound is split, this indicates likely pathology. The second heart sound is produced by closure of the aortic and pulmonary valves, indicating the onset of ventricular diastole. Again, closure of these valves is just one heart sound, but may be split, either as a normal variant, for example, when someone takes a deep breath in or lies down, or as a result of pathology.
Stethoscopes are also an important tool to check how well you are breathing and if you might have problems with your lungs. Stethoscopes are important not only when checking humans' health, but veterinarians use stethoscopes with their patients too. We hope you have enjoyed learning about how stethoscopes work to help humans and our furry friends keep healthy.
Hello everyone, thank you so much for joining us in this Connect2STEM activity. So after we learned about how the heart works and how the stethoscope works, let's learn how to make a stethoscope at home. For this activity, you're going to be needing a flexible wire, a flexible tube, medicine cup, tape, a balloon, some scissors, and 2 earplugs, and try to cut them down the middle like so. To learn how to make one, keep on watching. Okay, welcome back. So to start, grab your flexible tube and cut it into 2 pieces, like so. Each piece should be about 39 inches. It doesn't have to be exactly 39 inches. It can be off by 1 or 2 inches. Put these to the side and then grab your medicine cup and make a hole inside of it using either the scissors or any metallic object. You can heat it and then melt this part. The opening should be enough to fit 2 of the wires, and it should be tight so they fit exactly there, like so. And then we're going to use tape to cover this part up to close any openings in between. Okay, so after you're done with taping, it should look something like that. After that, grab your balloon and cut the beginning part of it, and you're going to end up with this piece, and we're going to use this part to cover this part. Like so. And then try to pull it as tight as you can so it's flat at the top. And then we're going to secure it with tape again. After you're done securing the balloon, it should look something like that. After we're done with this bottom part, this made the chest piece. Now we can move up to the top part, which is where the ears are going to go. Grab your wire, the flexible wire. For this part, I used about 15 inches in total and tried to bend it into this shape. And then after you bend it, we're going to grab the top part of the stethoscope and we're going to try to tape it like so that the flexible tube holds this shape. Make sure when you tape it to leave this much space between the flexible tube and the flexible wire so that we don't get this inside our ears, just to protect them. And then we can start taping. Start with one side. And use your tape. And now the next one. should end up with something like that. Try to make it as tight as possible so it holds its shape. After you're done with this part, it's optional, but you can tape it around here all the way so that it holds its shape instead of just keep opening like that, just to make it more tidy. I just want to show that after you tape it, it's gonna hold its shape way better, like so. And then you're gonna end up with this. And now to the last part. So we are pretty much done, except that we can't insert this tip into our ears. It's not safe. So what we can do is grab 2 earplugs and cut them down the middle like so. And then we're gonna grab one and try to cover the tip. And just, we'll tape it here, and now it's better and it's safe to insert into the ears. After taping it, it should look something like that, and we're pretty much done. So just to review, this would be the earpiece, this is the tubing, and this would be your diaphragm where you're going to be using it on the chest. I hope you all enjoyed this activity as much as we enjoyed making it. Thank you so much.
Well, thank you. That was very fascinating. It was very exciting to hear about all about the heart and how to make a stethoscope. So I'd like to turn it over to our team at the College of Pharmacy and let them continue.
Well, good morning and happy Almost Heart Day. Thank you for joining us this morning for our session on Wonders of the Heart, Hear the Beat. What we're going to do today is I have 2 of my pharmacy student colleagues, Helen and Ifra, with me today. And we're going to start off at home. If you've had a chance to make your stethoscopes, you can follow along. If not, you can make your stethoscopes later and also check with the video, but just to see how is it that we use a stethoscope. So I'm going to go ahead and turn it over to Helen, who will demonstrate how to use a stethoscope.
Thank you, Wendy. Hi, everyone. I'm Helen. I'm a pharmacy student as well. I have my stethoscope here. It's not a homemade one. It's one that we've used in class. So you already learned about all the different parts of the stethoscope. So if you have a store-bought stethoscope, the earpieces tend to have an angle to them. So like we said in the video, you want to have them pointing forward when you put them in your ears, so that way you can actually hear the sounds that you're listening to. If you put it in wrong, you won't be able to hear anything. It's pretty fun actually to hear the difference between when you can hear something and when you cannot. So on this stethoscope specifically, it has both the diaphragm and the bell. And so this one, it can turn for which side you're going to be using and listening to. Personally, I usually use the diaphragm. I find it easier because it's bigger. So when you are going to listen to the heart or some other organ, but make sure you put them in your ears correctly, facing forward, and then you would place it. Make sure to not be touching the sides, otherwise you won't be able to hear anything. And then I would be able to listen to my heart. I can hear it. So what we're going to do now is, if you have your stethoscope at home, we're going to use it to take our heart rate or our pulse. So your heart rate is measured in beats per minute. So that's 60 seconds. So instead of listening for the whole 60 seconds, which can take a really long time and a lot of focus, you can listen for a shorter amount of time. So you could do half, so you could do 30 seconds, or you could do 20 seconds, even 15. I like to do 20. I think it's a good round number. And then you would just listen for how many beats you hear for those 20 seconds, and then multiply it by 3 to get the number of seconds in a whole minute, because 20 times 3 equals 60. So I have my timer here. So we'll do the timer. If you have your stethoscope, You can do this. After this, I'll show you how to do it if you don't have the stethoscope. So put my stethoscope in my ears, place it so I can hear my heart. Okay, now I'm gonna start my timer. Ready, and count. Okay, stop. So I got 28 beats. So 28 times 3 is, oh no, 28 times 3 is 84. Thank you, 84. So my heart rate right now is 84 beats per minute. A normal adult's heart rate is anywhere from 60 to 100 beats per minute. And a child's heart rate would be a little bit different. Remember that for later for questions. So now I'll show you how to take your heart rate if you don't have a stethoscope. So most of the time you can feel your heart rate somewhere on the body. You can feel the heartbeats. The common places, excuse me, the common places would be right here on your veins, in your neck, or on the wrist. When I do it on myself, I have a hard time feeling it on my wrist, so I like to do it on my neck. But if you're going to do it on someone else, like a friend or your parents, it's probably uncomfortable for them to have you pressing on their neck, so you could do it on their wrist. So you would just push until you feel the heartbeat, and then you'd be able to count. Okay, so now we're going to do it like this. So I'm going to start my timer, and then you all can start counting your heartbeat or your parents' heartbeat, whoever you're measuring for. Okay, ready? Go. Okay, stop. That time I got 25. So 25 times 3 equals 75. So my heart rate went down a little bit, 75 beats per minute. Now, let's see what happens if we exercise a little bit. Will our heart rate go up or down or stay the same? So if you're participating at home, get up, jog in place. We're going to set a timer for 30 seconds, and then we'll come back and measure again. Okay, changing my timer to 30 seconds. I'm gonna stand up over here and jog for 30 seconds, okay? And go. Okay, stop. All right, now get back in place so you can feel your heartbeat. Ready? And count. Okay, stop. That time I got 35 beats. So 35 times 3 is 105. So my heart rate went up. So exercising makes your heart rate go up because your body is in need of more oxygenated blood. So it has to beat faster to get your body all the nutrients it needs. All right, thank you all so much for participating. I'm going to hand it back to Wendy for some questions.
Thank you so much, Helen, for a wonderful presentation. And again, just such a great way to show us that using simple devices, we can check how our heart is doing at home. I noticed that we had some great questions in the chat. One of the questions that we had that I wanted to answer was, what is the purpose of the fat that surrounds the heart? And it's often a little known fact, but the heart is actually surrounded by a kind of fatty tissue called the epicardial or pericardial sac, which has a lot of fatty tissue. And the thought behind the purpose of this is it kind of protects your heart, because when your arteries are pumping all that blood, this fat will sort of help to protect from some of the twisting and turning. And in fact, some think that the fat that surrounds your heart and protects it in this way actually might be a source for energy in times where there's a lot of stress on the heart. And then another great question that I saw in the chat is, what are we listening for with the stethoscope? And so like Helen demonstrated, we're listening for how fast our heart is beating is one thing. And also, depending on what part of a person what part of yourself that you're putting the stethoscope on, if you put it in a location, you might be listening to your lungs to see if they sound clear. You might notice that at the doctor's office, if you go in and you have a cough or a cold, they'll actually use the stethoscope to listen to your lungs to see if they sound clear or not. When we use it for the heart, a lot of the sounds we'll be looking for will be sounds where we expect all the chambers of the heart to pass blood in a certain way, but sometimes the valves, which are like doors that help us push blood through the heart, sometimes they won't be working right, and there'll be really characteristic sounds that doctors can hear to know if that's functioning properly. So we've had some super questions in the chat, and I'll try to get back to see if we have any other questions that I haven't addressed, but I thought one fun activity for today is to sort of share some lesser known facts about the heart. So we're going to have a little question and answer that you can follow along with at home. Okay, all right. So one fun fact about the heart, there's actually several fun facts I brought for today that I thought we could go through. Did you know? So let's see how many of these we can answer. Do you know how much blood the heart pumps per minute per day? I'll let you think about that for 5 or 6 seconds. So the heart is actually pumping 5 liters per minute, or 7,200 liters per day. So 5 liters per minute, that's a little abstract to some of us. So 5 liters is basically, if you look at all 5 of these drink containers, the orange juice, I tried to pick heart healthy drinks, the V8, the cranberry juice, coconut milk, and this 1 liter of water. So basically per minute, your heart is pumping all of that through your body. So you have to think about it. And we're really, it's a pretty amazing organ. Next fun fact. If you were to take all the blood vessels in your body and lay them out in one long line, how far would they stretch out? And I'll give you a couple seconds to think about that. Okay, so for children, and I chose children because obviously adults are going to be a little larger, so we'll have a little bit longer length in terms of how far they stretch out. But did you know that your blood vessels are going to actually stretch out about 60,000 miles? Okay, that's more than twice around the Earth. That's pretty amazing. Now, I know some of you may be thinking, well, I'm not sure about that. But what it is when these blood vessels will also include your capillaries, those teeny vessels. So when you actually line them up one after the other, it's pretty amazing to think that your heart is pushing blood through all of those different blood vessels. Okay, next. Now, some of you may have heard, whether it's from family, friends, or even on TV, people talking about cardiac bypass surgery. And there's a lot of different surgeries that can be done on the heart. It's very amazing, all the things that we can do medically to help people who have problems with their heart. But a common surgery is called cardiac bypass surgery. And so I'll let you think for about 2 or 3 seconds about what that might mean before we go into the answer. So cardiac bypass surgery is actually an absolutely amazing surgery. What happens is for people whose arteries in their heart get blocked or narrowed by a buildup of fatty-like materials, we call that atherosclerosis, when they get clogged up and they can't push the blood through as well, our medical team will look for ways to help the patient. And one way is they can actually take some of your vein in your leg, they will cut it out and they'll use it and they'll graft it on, or they'll put it onto the heart and bring it from where the vessel is unblocked to the other side. So it's sort of like patching up your heart in a way with another vein in your body, which is pretty amazing if you think about it. So if you've ever met somebody who's had cardiac bypass surgery, now you know what that entails. Okay, some sort of fun questions. What animal has the largest heart? And I'll give you a clue. It's not dogs, even though they're really sweet. It is actually the blue whale. So a blue whale has a heart that's 180 kilograms. And for those of you who are more comfortable with pounds, that's 400 pounds. So that's pretty amazing. That's larger than, that could be several humans, the size of several humans, basically. And so if you think about it, that makes sense because of the size of the blue whale, but that's pretty interesting. So that's the largest heart on Earth belongs to our blue whale. How many hearts does an octopus have? And that's not a typo, it's hearts. And the answer is an octopus has 3 hearts. So actually, it has one main heart, and then it has 2 accessory hearts. But I just wanted to let you know that not all animals have only one heart. So that's our question and answer session for today. I'm going to go ahead and hand it back. I appreciate you joining us today, and I hope you learned a lot of fun things that you can share with your family and community.
Thank you so much, Wendy. That was really wonderful. And thank you for your team and all the different things they taught us about the heart. We did have a couple of questions that popped up in the chat that I thought were very interesting. One of them is, how do I make my heart healthier? You mentioned the heart was a muscle, and I know that when I exercise my muscles, they get healthier. How do I exercise my heart muscle?
You know, that is such a wonderful question. So there's a lot of great things we can do to make our heart healthier. The idea of exercising your heart is a good idea. So this is why we recommend that if we want to keep healthy, we want to keep exercising, get our heart rate up about at least a half an hour, 40 minutes a day, or 3 to 5 times a week. And that gives our heart that exercise to be fit and to work well. And then another thing you can do to help your heart is to eat foods that, if you will, make your heart healthy. So lots of fruits and vegetables, fibers, these kind of things will really help your heart. There's different kinds of there's actually different kinds of fats that are really healthy for your heart. There's fats called omega-3 fatty acids that you can get in fish and nuts. And this makes your heart very happy because it helps it to work better. So the foods that you eat, and eating a healthy diet, exercising, and taking care of yourself, getting good rest, these are just wonderful ways to take care of your heart.
Wonderful. Well, thank you so much. And we want to really thank our team over at the College of Pharmacy at the University of Arizona for their wonderful presentation and for joining us today on this Connect to STEM Saturday. So thank you all so much. All righty, I'm going to go back to sharing my screen and let's have a thank you from our Be Kind team.
Learning about STEM is fun. Be sure to check back for more Connect2STEM TV. There's lots more to do. Don't forget you need to register here. Special thanks to our sponsors Banner Health, APS for their great support. And be sure to follow Connect2STEM on Facebook.
Well, thanks, Sunny. And now I'd like to show you a special video from our AZ Bio 5 team. And this is one about a program that would be of great interest to our high schoolers and also those that will be heading into high school.
My name is Brooke Moreno, and I'm a program coordinator for the Bio 5 Institute's KEYS Research Internship at the University of Arizona. I am also a proud alum of the 2009 KEYS class. Little did I know when I applied to be an intern at the age of 18 that over 10 years later, I would be a leader of this incredible program. Before I began my KEYS internship, I was an undecided major and had never set foot on the university campus. I was assigned to the lab of Dr. Hedwin Brooks, and what a perfect match that was. Dr. Brooks and the KEYS staff helped me realize what I was capable of, and Dr. Brooks invited me to continue in her lab once I started college. Participating in the KEYS program opened so many doors for me. When I discovered they were hiring a student worker, I jumped at the opportunity to help other high school students explore their scientific passions. During my time as a student worker, I fell in love with education. So much so, I switched my major to science education with an emphasis in biology. I am now a certified science teacher and a full-time staff member.
In order to share the screen,
I could have never known the great impact KEYS would have on my life. I get to wake up every day and be a mentor to the
everybody to be where they need to be. My first class.
Thank you very much. So Christian, if you could stop, if you could mute your line, please. Thank you. All righty. Well, our next presentation will be coming up soon. And so let's go ahead and take a quick little break. And we'll be back at 10:45 with Makerspace Magic and Drones to the Rescue. See you all in just a little bit.